Hi everyone, my name is Bala Juluri. Today I'm going to talk about visualizing San Diego's COVID data in a browser. So the main motivation for this project, this was just a side project of mine, was to better understand San Diego's COVID-19 data. It all started early last month, when San Diego County was. I cannot move forward. Okay, now. San Diego County was giving this PDF that had cases of COVID-19 with different zip codes. I looked at this PDF and I was able to tell like how many cases were there in my zip code, but I didn't have a good idea as to like what's happening in other places of San Diego, like in my friend's place. So I think I thought like a table is probably not a good way to visualize this kind of data. Probably a better way would be to put those cases, the case numbers on a map. And also they were changing this, they were updating this PDF file like once a day or twice a day. So I wanted to see like how things were changing. Now I think they have better visualizations. When they just started, there were not many. So that like kicked my interest to, come with a better visualization. I wanted to see what's happening with time. So I wanted something like interactively see what's happening with dates. And I also wanted to do it in a browser because, I can just send the link to someone and they can, look at it and get their own insights about what's happening. So I started with this called visualization pipeline. So what I do is I request the county website for a PDF file. And if it's updated, I do something. If it's not, I don't do anything. If it's updated, I convert the stuff that's inside the PDF into a pandas data frame using Tabula, and then put that data into a JSON file, append it to a JSON file where everything is organized by date. Then I load that JSON file into pandas again and clean up some stuff, and then merge it with San Diego's map, which is in the form of GeoJSON, and then give it to Bokeh, which is a Python library to create visualizations. So Bokeh takes this data and puts it into a standalone HTML. And then I put this standalone HTML inside my blog and publish it. So this procedure happens daily, every 3 hours between 6 a.m. to 9 p.m. So using cron. So let me show the visualization, and also I can probably post this on the chat so you guys can play too. How do I do that? No. Any ideas how to post on the chat?
I might be able to handle it.
Okay, someone can post it. But anyway, so if you go there, it looks like this. So this page gets updated whenever there's an update from the county side. So this one just got updated like 5 o'clock today. So the number of cases now we have is like 7,100 cases, and you can see with time they're just going up and up. So we can also calculate the number of new cases every day, and so we are on average like around 100 cases per day. And this is the visualization I was primarily interested in. So this is a San Diego map, and each polygon here is one of the zip codes. So one can, and the circles here represent the number of cases, or the size of the circle is proportional to the number of cases. So we can use the wheel, all these tools, and then go hover there and look at the number of cases there and what are the new cases there. And you can see like primarily most of the cases are on the south side of the county. We can also see with like time how things are changing. And we can also look at the new cases. So these are the new cases. So today, if you see like most of the cases are from 9 to 105. So yeah, we can also change this and try to see if there's any patterns. And this is, so the problem with this visualization is that it doesn't normalize the population in that zip code. So this one normalizes that with the population. And even you take care of the population. You normalize with the population. Still, the south side of the San Diego seems to have disproportionately high number of cases per 100,000 people. So there are other visualizations. If you are interested, you can look at it. But yeah, like there are interactions you can play with. So let me go back to the slides. So the nitty-gritty details of all this implementation is in this Jupyter Notebook link. I'll post the slides at the end of the talk. You can look at it. So most of the stuff is done by Bokeh, which is the visualization library. So let me talk about it. So it's a Python visualization library for web browsers, and it's primarily used to make like plots, dashboards, and data applications. So you write your code in Python, then it gets converted, the visualization gets converted into a JSON object, and this JSON object goes into like is consumed by a Bokeh JS client library in your browser. So it has like rich tools for like all this data visualization and interaction tools. And the best part is you don't need to learn JavaScript. I'm not a professional programmer, not a data scientist. So this helps me a lot. Like I just want to focus on Python and do stuff in Python and be happy in my Python world. So that's the good part. So there's some resources if you're interested. Please look at it. I was able to learn very quickly, so I think it should not be that hard. So one thing that confused me, it was like, how do you use Bokeh? There are different ways you can use it. One of them is you can directly use them in Jupyter Notebooks. Like the way you use matplotlib in Jupyter Notebooks, you can use it like that. Or you can run it as like an application where it's a server. So you're running a Bokeh on a server, and then clients can connect to that server, and data can synchronize between these two entities. Here is where you use like 100 Python code. But I choose a different way, that is a standalone HTML way, just because I didn't want to have a server set up. And so this standalone HTML output contains all the data. Like in my case, it's all the data of like 1 month's worth of data in that HTML. And then there's JavaScript that filters and does all that interaction, and CSS. So so the negative of this using standalone HTML is you have to still write a little bit of JavaScript, that is callbacks. And the other thing that I want to tell is this Tabula.py, which is a wrapper on Java's Tabula library. This is the one that helped me convert PDF to data frame instead of me like reinventing the wheel. So it can detect pretty well like the tables inside a PDF. Or you can, if you're having trouble, you can use like a read PDF with a template. You can make a template and give it to that function, and then it will do a much better job. So there's some resources here. Other things that helped me was mapshaper.org. So when the San Diego's GeoJSON map, I downloaded it. It was pretty huge file because it has like very high resolution. When you have that inside an HTML file, the file size is big, so it takes a while to load. So I was able to use this map shaper to simplify the JSON file, GeoJSON file. And the last one is the file comp. This is a module in, this is a part of Python standard library. I didn't know about this, but this is how I compare between the PDFs if they have changed. So it can say whether the PDF is different based on the content or the status of the files. So these were the helpers. So I think that's all. So if you have any questions, please let me know.
Thank you.